Assalamu alaikum and hello everyone. Welcome to Mathematics with Shahab Yaqub. So now in this particular video, we are focusing on P3 and this was a practice test that was on two topics, trigo and differentiation. So trigonometry is there, differentiation is there, and let's look at the paper. So that was question number 1. It says given that cos x minus 30 is 2 sin x plus 30, show that. This is from this particular year. Now this is all about the exact form. So the exact trig ratios will be used over here. We know that sine of 30 equals to half, so s equals to cos of 60. And similarly, sine of 60 is root 3 over 2. That is the same thing as cos of 30. So the rule is sine of 90 minus theta is cos theta, cos of 90 minus theta is sine theta. That is applicable over here. Now first of all, we use the addition formula, cos A minus B, cos A cos B plus sine A sine B. Sine A plus B, sine A cos B, cos A sine B. We write it out. Now what I have done in this particular one is that I did not insert in the value. First I open up the bracket. Then I selected all the like terms together. This is a sin x term, this is a sin x term, transfer on the left. The cos and the cos transfer on the right. Sine divided by cos is tangent. So tangent equals to this. Now let's take something common. What should be taken common? So I have taken this half common. I have taken this half common. This half cancels out and I get this exact value. So that was the first part. A lot of people struggle with this. I mean, keep life easy. Write it out simply. Improve your basics and it will not be an issue. Now the next one, it says hence solve this equation. Now tan x equals to this. I have used the calculator. I have simplified. I'm working in 5 significant figures. That's good enough. Tangent is negative. That means we are talking about the second and the fourth quadrant. Range of values of x is between 0 and 360. Non-inclusive. Basic angle is always calculated with a positive ratio. A very small angle came out. Expect the unexpected. And then x is in the second quadrant. It's 180 minus basic angle. Fourth quadrant 360 minus basic angle. Work in at least 4 SF for the working. So that the very final answer is 1 dp. My bad. This is degrees. So work in at least 2 decimal places. That is at least 2 dB. And final answer 1 dp and make a habit of writing it. So therefore final answer is 1 dp. So now question number 1 is done. That's the mark scheme. That was the show part. 173.8, 353.8. All good. Next one. Now it says by first expanding tangent 2 theta plus 2 theta, show that the equation may be expressed in this particular format. So now this is a question of disguised quadratic equation. Tangent 4 theta can be written in terms of 2 theta using the double angle. So the official formula is this thing. That's how it's written. Tangent 2a, 2 tan a over 1 minus tan square a. So now instead of a, what do we have? We have 2 theta. And instead of 2a, what do we have? 4 theta. So that's how you have written it. So now first of all, tan 4 theta is written as this and then it's replaced. So now what I have done is that tan 4 theta is half tan theta. And I think I skipped one step. Let me just shift it a bit over here. Shift these two things over here because this looks a little bit abrupt. So let me first write over here. This is 2 tangent 2 theta. 1 minus tan square 2 theta. This is identical to half tan theta. So I did it a little bit in a hurry. Now it looks better. This thing is this thing. This thing multiplies with this red one. And then you expand. But now wait a minute. You also have to simplify this thing. That is tangent 2 theta. That is tangent 2 theta whole square. So let tangent theta equals to t. tangent 2 theta equals to 2 tan theta 1 minus tan square theta. This is 2 tan theta 1 minus tan square. 2 tan 1 minus tan square. Now over here, this is simple multiplication, just the numerator. Over here, expand 2t whole square 4t square. 1 minus t square 1 minus t square square. Then I took LCM as it is. And then it so happens that these two are the same, so it cancels off. So, and then you simplify, expand, do everything that's possible, and then you get this disguised quadratic equation. So what do we have? We have tan power 4 theta plus 2 tan square theta minus 7 equals to 0. That is right over here, and this is for 4 marks. 4 marks means a lot and lot of working. The next one. Now it says hence solve this equation. So hence solve this equation, that means hence solve this disguised quadratic equation. Let m is equals to t square, therefore m square is t power 4. So we have m square plus 2m minus 7 equals to 0, and since this is P3, there are few things that factorize, but mostly it is about quadratic formula. So in this case, yes, it's about quadratic formula. And then we are working in decimals, take care of accuracy, work in at least 4 significant figures. Tan square is negative, no solution, can't take square root of a negative number, or for that matter even root. Over here we are getting plus minus values of tan by taking square root. All 4 quadrants is possible, but we are restricted by this range. Basic angle is this thing, first quadrant, second quadrant, final answer, 1 decimal place. So now this is all good, all clear. 53.5, 126.5, 53.5, 126.5, all good. Now question number 3, again trigonometry. This time it's about compound angle, but not the whole thing, just a bit, not the normal equation or something like that. Express 5 sine x minus 3 cos x in this format where r is positive and alpha is acute. Give the exact value of r, alpha correct to 2 dp. 5 sine x minus 3 cos x, start with sine, convert to sine. This is a, this is b, that is the shortcut that I teach. R is a square plus b square under root. I mean, whenever possible, without compromising on the quality, on the concept, if shortcuts are applicable, I would teach that. So r comes out to be root 34, that is exact. Alpha is tan inverse of 3 over 5, that comes out to be this much. It's in radians, so make sure your calculator is in the radian mode. Now the next part, it says, hence state the greatest and least possible values of this thing, the whole thing square. If there was no square, the greatest possible value would be root 34 and minimum would be this thing, because that's how the graph would be drawn, something like this. And of course a bit displaced. But with the square, this and these two are giving the same answer. Now choose a value in between. So now it's going up like this, down like this, and there is the 0 value. So now when we square it, the thing would be that you have to take of this value, think of this value 0, 0 square is 0. Refer to the square trig sketch of P1. Very recently I have made a video on this particular thing. And do watch that one, even though that's relevant for P1, but the knowledge is exactly the same. So now the final answer, that is this thing, the maximum value is root 34 and the minimum value is 0 because of this squaring over here. Greatest 34, least this thing, 0.54, root 34, all good. So now trigonometry is done. Now it's time for the next star, that is differentiation. The curve with the equation has one stationary point. Find the coordinates of this point. Determine whether the stationary point is a max or a min. So now it's an application of quotient rule. This thing is u. So u is x. This is u prime. And then this thing is v, e raised to power of 1 minus x. Therefore, v prime is this. And then product rule is crisscross like this. U, v prime, v, u prime with a positive sign in the middle. Whenever it's a question about exponential, it's always possible to take the exponential common out. So exponential is taken common out. And it's asking for the stationary point, dy by dx is 0. So therefore dy by dx is 0. This thing equals to 0 has no solution. E raised to any power can never be 0. It can never be negative. and therefore x comes out to be positive, half. Now plug in y. So y is this thing. You plug it in and we get half also. So therefore the coordinate is half comma half. Nothing is done. Determine whether it's a max or a min. So now we have dy by dx is this thing. Now again we have u over here, that is u over here, and this is u prime. Again more application of quotient rule. This is v over here, this is v prime over here, again crisscross. That is u, v prime, v, u prime. Again, what are you taking common out? You have the liberty of taking e raised to power of negative 1 minus 2x common out. Of course, you can also take negative 2 common out. And then we are left with this. Now, when we plug x is equals to half, the second derivative is coming out to be negative, which means it's a maxima. So I think it's a pretty straightforward question, provided you know your basics. So that is half, and yes, it's a maximum point. Next one is about parametric. The equation of a curve are such and such, x in terms of ln. So this thing goes down, derivative goes up. This is an application of quotient rule. U is t, u prime is 1, v is 2 plus 3t, v prime is this. Now the quotient rule, what it says is this. Derivative of u over v, that is v u prime minus v u prime. No, I've written it the same thing. V u prime minus u v prime over v square. So that is what's done over here. Simplify these things and then you are getting this. So be very, very careful with the division, multiplication, all these things. Now the very nice question which is this. Show that, it's the same question, show that the gradient of the curve is always positive. They're giving you 5 marks. Why in the world are they giving you 5 marks? They're giving you 5 marks because how will you prove? So this is a $1 million question. Now you have to focus on ln. We know that ln will exist if this thing is positive. When we draw the graph of y is equals to ln x, the domain is x is greater than 0. When we draw the graph goes like this. So let me draw it properly. The graph goes like this. And over here, that is the asymptote over here. This is the y-axis. This is x is equals to 0. This is 1, 0. So the domain is log only exists for positive values. So over here, this is 2 plus 3t has to be positive. If this thing is positive, this dy by dx has this thing. This thing positive means this thing positive. This is also positive. Product of two positive is positive. Yes, you have to write few English words over there. So maths is not just about numbers. Math is about logic. Math is about convincing. So now these questions, they differentiate between the person getting an A star versus an A. Person getting an A versus the one getting an B. These are the type of questions. So you should be very, very well versed in it. Find the equation of the tangent to the curve at the point where it intersects the y-axis. Where the curve intersects y-axis, x is 0. When x is 0, therefore ln 2 plus 3t is 0. Therefore 2 plus 3t is e raised to power of 0, which is 1. T comes out to be negative 1/3. When t is negative 1/3, the corresponding value of y is also negative 1/3. And t is negative 1/3, y is 1/3, x is 0. Keep that in mind. So don't mix this up. This is x, this is y. Gradient of tangent is dy by dx. That comes out to be 2/3. And then you find the equation of the tangent. You can either leave the answer in this form, or 3 is common, write the answer in this form, cross multiply, write it in this form, or write in the form ax plus by plus d equals to 0. So now over here, that is it. 3y is equals to 2x minus 1. Question number 6. The equation of a curve is this. Show that dy by dx is this much. Find the coordinates of the stationary point where the tangent is parallel to y-axis. So derivative of this thing, differentiate both sides with respect to x. X cube becomes 3x square. Y cube becomes y square. And then this is, this is 3y square and dy by dx. Now a little bit of color coding should be there so that we know exactly which one is which term. This x cube is this thing, 3x square. This green one, that is negative y cube that is negative 3y dy by dx. So whenever you differentiate y with respect to x, whenever we are talking about implicit, then we have to write dy by dx for compatibility. And what about this thing? 3x into y squared, that is this whole thing. This is u, this is v prime, this is v, this is u prime. Derivative of a constant is 0. And then we collect all the dy by dx together. So this is dy by dx over here, this is dy by dx, this is dy by dx. What terms are there? 6xy minus 3y square. And then the other terms are taken to the other side. I have taken negative common, I have taken 3 common, they both become positive. I have taken negative common, I have taken 3 common, this is it. So negative 3 cancels out and we are getting this thing. It's necessary, it is a must, it is mandatory. There is no escape, you have to write the answer in that particular format. So now this thing is all done and dusted. Now it says tangent is parallel to y-axis. When tangent is parallel to y-axis, dy by dx is undefined. So numerator over denominator is undefined. What makes a fraction undefined? When denominator equals to 0. So this is the denominator. This is equaling to 0. Never divide, always take common. Y equals to 0, y equals to 2x. Now solve simultaneously with equation of curve. That is the equation of curve. And what you have to do is to substitute. So now when y is equals to 0, this thing disappears, this thing disappears, x cube is 5, x is cube root of 5. Leave the answer in the exact form. When y is equals to 2x, plug in y over here, square it. Plug in y over here, cube it. Simplify, simplify, simplify. Cube root of a positive number is positive. Answers, let me highlight it. The answers are cube root of 5 comma 0, 1 comma 2. Cube root of 5 comma 0, 1 comma 2, and I think that's about it. So this was P3. This was test number 2 that I've taken recently. That is definitely a practice test, and it was about trigonometry, and this is about differentiation. Hope you have enjoyed the video. Let me know in the comment section. Take care, everyone.